It's an equation, so we're solving again. So that's a good thing, because we said solving was nicer, right? We just gotta remember simplifying and solving have two different sets of rules. But this time, you're going to create the rational terms. So that's what you're gonna be doing. You're going to be creating the irrational equation, and then you're going to be solving it. So it's kind of like a max min problem. Like we learned how to complete the square, we learned how to do the technical stuff, and then you had to create the two binomials and then complete the square. So we've done this before. We've created the equations. Okay, all right. Okay, so sometimes it's easier to use the table. I find it easier to use the table. Some people hate the table. Tables are not mandatory. They just help keep your information organized. Okay? So if you hate the table, figure out if you hate the table or you hate this lesson. Step one. Step two, decide what works for you. Okay, once you've actually solved it, you're going to check your solutions. Check that they're not your MPVs. And then you have to check, we talked about this yesterday, of whether they're reasonable for the context of the question. Like if it was a distance and you got a negative, we'd reject it, right? Makes sense? We talked about this yesterday? Okay, so, you know what? I want to jump to example 2. Okay? Flip the page. Just flip the page. I have example 1 there, but I think it's one of the more difficult ones to grasp. So let's start with something that we're all familiar with. Speed, velocity, some of you have taken physics courses. So my expectation is that you know that speed is distance over time. And we're dealing in speed, not velocity, because I'm not worried about the directionality of it. We're just worried about how fast we're going. So I expect that all of you know this formula. The distance divided by time. Okay? Everybody know that? It's nowhere on your plan sheet. It's like one of those, it's like a secret formula that we use all the time. I don't know. Anyway. Okay, so 2 trains leave the station. A train is scheduled to run 160-kilometer return trip between 2 cities in Manitoba. The average speed is decreased by 16 kilometers an hour, and the trip will take half an hour longer. All right, okay. I guess we need to know, what do we want to solve for? Average speed? You want to go home now? Okay, too bad. Not going to happen. All right. Do you guys have something on there, or is it just that? Okay. All right. Okay, so let's talk about our average speed. So we want to solve for our average speed. So do we know what the average speed is? So let's call it. Let's do arbitrary and call it S. Make sure your S doesn't look like a 5. Okay, so if the train slows down, how much slower is my speed? No. Right, because like if I was traveling 100 kilometers an hour and I go 16 kilometers an hour slower, it's going to be 100 minus 16, right? We just don't know what our average speed is. But it would be the average speed minus 16. Are you guys good with that? All right. So we know, what do we know? Distance. So it's a return trip. Okay. So that would be like me driving to Woboden and back. Will the distance change on that trip? Okay, have you been to Woboden? There's one road, right? We got the highway, right? Like, you know, this is why I picked Woboden. Like, we are on the highway. There is no, and distance is going to be the same, right? If it's 80 kilometers there, it should be 80 kilometers home. Does that make sense? So the round trip was 160. So we know that it should be half, right? And it's a distance thing. Now my speed can change and my time can change, but distance is one of those things. If it's a round trip, like like I said, if we go to Woboden is not picking up, and the town of Woboden isn't moving further away in the time, right? So it's 80 and 80. Okay, so the time, do we know on average how much time it takes to do this trip? No, so let's call that T. Okay, no, if it takes me 40 minutes to drive, T plus half an hour. Okay, so this is the thing. What's my speed measured in? Hour. Okay, so what are we going to add to the T? You keep saying half hour. What does that mean mathematically? Okay, so we're going to add, not times. We're going to add a half an hour to it. Okay, this is where people screw up. They put 30 here. Add 30 minutes. And that's not a true statement because our speed is measured in hours. So this half hour has to be in relation to hours. So if it says 45 minutes longer, we would have to put 0.75. Does that make sense? You have to keep them in the same units of measure. That's the trick to these questions. And there'll be a lot of speed distance questions. Okay, good job, everybody. Good job. All right, so we have the average speed and then we have the slower stuff, right? So that's why the table I find helpful to just kind of keep me organized. Okay, so I'm going to make two equations. My average equation, and the average equation is perfect. S equals 80 divided by T. That's exciting. Anything else to say about that? Okay, so what are we going to do? Then I'm going to make my slower equation, and that would be S minus 16 equals 80. Right. Mention you're looking at me? Yeah. Like,
I have a different question.
okay, ask your question.
Yeah, it's like, do you consider the trip like one side or they are?
It's a return trip, and the way I indicated that to you in the question was I said together it was 160.
Yeah.
So that's why we split it to 80.
So the confusion, we consider time T plus 1.5 for just 80 kilometers.
Right.
But it shouldn't be like for 160, like 160 kilometers takes half an hour extra rather than
Okay.
80 kilometers.
If the average speed is decreased by 16 kilometers an hour, the trip, so we're looking, okay, I see what you're saying. No, we're doing well. Not the whole trip, just half the trip.
Oh, it's
Like
one side.
one direction, yeah. Sorry. So that's my fault, not your fault. Okay. So I have two equations. I have my orange equation and my green equation. All right. So now I'm going to set them equal to the same variable. Okay, so you want to set them equal to S. You can do it to T if you want, but I think there's more rearranging if you set it equal to T. So what I'm going to do is this is already set equal to S. So we're going to set it equal to the same variable. So this one's going to change to S is equal to 80 over T plus 0.5 plus 16. How do you guys feel about that? Okay, there shouldn't be, we move 16 from one side to the other. If that's your breaking point, you're not doing well. Okay. All right, okay. So what we've said mathematically is we've said 80 over T is equal to S. You're saying those things are exactly the same thing, right? That's what that equation is saying. You're also saying that S is equal to 80 over T plus 5 plus 16. Plus 16. So you're saying that these things are equivalent. So this thing and this thing are equivalent, right? So we're going to set those equal to each other. So 80T okay. So now you have a rational equation. Right? Yes. Now we're going to solve it. Cake factor, no. NPVs? I love it. We're like punching on those crazy fools. Does that one seem reasonable? -1/2 of, what's time? T is time, right? We're gonna have -1/2 hour, that means you're gonna go back in time. Okay. We're gonna leave it in our NPVs because that's just the math behind it. But I need you to understand that that's not realistic. Not logical. Sometimes the stuff we do in math is not logical. It also makes sense that T can't equal 0. Because if I go back up to this formula, if I divide by 0, the world collapses on itself. All right. And then it's just going to be back. It's going to be back. Okay, so now common denominator. You need both. Because remember, that's a set. Right? That's a set there. So I'm going to need both of them multiple. Who do you just look super impressed? This is exciting. Yeah, but you put the 0 on the bottom now. You didn't put the 0 on the bottom.
I did.
You didn't.
Well,
Okay. So again, I'm multiplying tops only by the common denominator. Now I'm going to cancel stuff out. All right, so I'm going to have 80t plus 40 equals 80t plus. Okay, we're going to try to do this all in our head. Ready for this? If I times the t through, so that's going to be t squared half t. Right? Where's the t squared? So this would be 16t squared plus 8t. All right. What do I know I have to do right away? Combine my terms, and I'm going to end up with factoring, right? I'm going to end up factoring because this has a squared on it. Can I do something? You guys might not like this. They're both on either side. I'm just going to cancel those out. I mean, I'd be subtracting 80t from this side, subtracting 80t from this side, and I'm going to get 0. And normally I tell you to combine these two and get 88 and then take your 80 away, but I think where it's glaringly obvious, one on either side, I can just cancel it out. So I'm going to have 0 on this side, I'm going to have 16t squared plus 8t minus 40. And you guys know why I kept everything on the right-hand side, because my t squared is positive. These are little tips and tricks that are going to hopefully make your life a little bit simpler. Okay, so I'm looking at this. What can I take out of all of these? I can take an 8. I can take an 8. So let's take an 8. And anytime I can reduce the numbers I'm going to multiply by, is that right? Okay, so -10. That doesn't seem right. So that's 1 and 10. And what did I mess up on?
you have wait, the first 80, did you use up plus 0.5? No, everything's correct.
This is all correct.
T plus 0.5.
What are you talking about? I don't know what you're yelling at me about.
No,
Why are you yelling? What?
This is 16, there's a T plus 0.5.
Oh,
And how do you do it? I mean, why?
okay. I need you to breathe because I can't understand
So,
Go again.
so the first 80 over T, T gets taken out, the only time that like the drop the time is 0.5.
Are you on this one?
No, the first one, look.
So I did 80 times T is 80 T, 80 times a half
Okay,
is 40.
the other 16 T would be.
Oh, guys. Okay.
We need to use the.
What did I do? I got an 80.
Wait, what?
Okay, hold on. Hold on. Hold on. Okay, so I'm in a mistake somewhere. Are you guys ready for this? The matching is right. Oh, God, that hurts me. There's something wrong with the question. Do you guys want to fix it or do you want to abandon it? Abandon? Well, this isn't going to work if you have nothing that works. Woo. Woo. Do you guys want to know what the problem was? These shouldn't have been busted down into 80s because this was talking about the whole round trip. So this should have been 60 and 60. 160 and 160. Are we abandoning this? Okay. All right. I'll come back to it, but we're going to abandon it. Do you want to go up to the hard one or down to the same time? All right, let's hope I can do the hard one better. All right. Okay, what am I doing? Okay, the paint one. Oh, this one I don't enjoy. Okay. Still, it takes 4 hours to paint a room. Jose takes 3 hours. Now, we're trying to figure out how long it will take to paint the room if they work together. If any of you say 7, I'm going to cry. Okay.
No, let the one person do and the one person.
And then it's already done.
And then.
3 hours and you're done.
Like, that would take the room to know how long it took them to paint, so.
Well, they would know how long it takes to paint a room that size. Because chances are in Thompson, all the houses are pretty similar. Like, right? Okay. So what's the fraction of the work done in 1 hour? Okay, 1/4. 1/3. That's pretty easy, right? Okay, so the work done in T hours. T4. Oh, that's supposed to be a T. Okay, so how much together the work done in T hours, this is going to seem weird, this is like the leap of faith that I'm going to ask you to take. It would be T over T. The reason why is because it's going to take them some sort of in T hours, but they should finish painting the room, right? So however long in T hours, which we don't know, but that should be what it takes them to finish the room. So that's T over T. That's the one job, okay? So we know that Stella can do it in some time, plus Jose's time is going to equal T over T. Now what's T over T? 1, right? T divided by T is 1. It's the one job. You need to complete that one job. Non-permissible values? Okay. T cannot equal 0. Okay. Common denominator. Should I simplify this first? That might help us. Okay. So T over 4. Right? When you can simplify a term, you should do that before you do the common denominator. What's the common denominator? It's 12. That's nice. Don't you feel good with that? Okay, so yeah. What do you mean? Because it said how much work is done in T hours, because we don't know. T is the unknown, right? How much time is it going to take to paint the room? Well, I know however long it takes to paint the room, Stella can do it in a quarter of the time, right? And same with Jose. And we know that the total T, when Stella and Jose are working together, has to equal the denominator, because it has to be finished. Like, it can't be a fraction down, it has to be completed. Right. Hence the statement. Who, what? Oh, yeah, sorry. The common denominator, I can write it down over here, is gonna be 4 by 3, which is my 12. So 4 goes into 12 3 times, 3 goes into 12 4 times. So I'm gonna have 3t plus 4t equals 12. I know I'm just gonna do simple factoring. So 7t equals 12. $1.7. So if they both do it together, it's only going to take them about 2 hours. That's not 71 minutes, it's 71 parts an hour. I can do that. You guys work 65 minutes in this classroom? Right? Like, it's not like, we're not paying, we might pay you by the hour, or we might pay you by the job, depending on how you prefer to be paid. Oh, I feel terrible about that second example. Hardest lesson in history. What? You should get paid to be here. You're getting paid to be smart. Okay, we're going to jump to the third one. You with me? Yeah, of course. All right, this was the one I was trying to do. Okay, the Scallion family. You're very cautious people. We are driving to the lake at a rate of 90 kilometers an hour. We return home on the same highway at a speed of 60 kilometers an hour. I don't know what we were doing, but we were driving very slow. If the round trip took 2 hours, how far does the Scallion family live away from their house? Okay, so we're doing speed again. I'm going to make a table. So I have it there, and I have it back. You guys okay with that? Very technical table. So what did we do? Does it matter? I'm going to do speed, distance, time. Nope. Okay, there's my fancy table. So there means I'm heading to the cottage, and back means I'm heading home. Okay, this is the one that makes sense. Okay, so speed. Do I know my speed going there? 90 kilometers. My speed going home? 60. You're very cautious driving family. Or it's blizzard. Why am I having okay, time. So the round trip, so that means there and back to 2 hours. It definitely can't be one each because I'm going to get there faster than I would on the way home, right? Because I'm driving faster. Do I know how long it took me to get there? No. So let's call it T. Do we know how long it took me to get home? No, but we do know that the whole thing was 2 hours. So if it took me an hour and a half to get there, 15 minutes to get home, which isn't realistic, or if it took me half an hour to get there, and it took me an hour and a half to get home. And the math that you guys do in your head is subtraction. What are you subtracting from? So my total of hours, because it's the 2 hours, and I'm subtracting however long it took me to get there. Does that make sense, everybody? Okay, so this is where I screwed up. I was doing 2 different questions in my head. So the distance, this is the Woboden thing. the distance.
It'd be the same.
It would be the same. We just don't know what it is. So it's gonna be, right, we're not picking up my cabin and moving it, it's the same distance. See, I knew I was gonna do it right eventually. See, and that's the thing with this.
You make your own music.
Exactly. Start later, I'm gonna do much better when I start with nothing. Okay, so we have the there check. So I'm gonna make the formula. So it would be 90 is equal to D over T. And then we have the back trip, which is 60 is equal to D over 2 minus T. Okay, so what do I do from here? Okay, so we got to rearrange both to equal one variable. D. Okay, D. I was like, okay, D seems a little odd, but I'll roll with it. D. The reason why we picked D is because if you notice, there's nothing attached to the D. Like this is a T and this is 2 minus T. I'm gonna have to do more fancy math. I don't want to do that. So we're gonna have 90 T is equal to D. And we're going to have 60 times 2 minus T is equal to D. How do you guys feel about that? That's not hard, right? This one I promise will work. Okay, so they're both equal to D. We set them equivalent to each other. So we are going to set them these parts equivalent. So 90 T is equal to 120 minus 60T. We good? No? What? So what am I going to do with this? We're going to do this, right? We're going to move stuff around. So we're going to have 30T is equal to 120. Oh, see, this is why you don't let me do math. Oh, how about 120T? Is that better? What happened to 120? Remember I said it was going to work out? Not if I don't do my math right. All right, so now, whew, third time's the charm. Last name was curling, it was like 10th time was the charm. So T is going to be equal to 4/5. Okay, at least I can do a 5, that's good. Okay, so that's 4/5 of an hour. If this makes you feel more comfortable. Okay, so this is the trick. This isn't answering your question because the question was asking what's the distance, right? So you can substitute this T into either of these equations because the distance is the same on both of them. But which one are you going to use? The easy one, right? And I'm probably going to use this one, right? Like I'm probably going to use this one. This I had to multiply stuff and I didn't do it well, so I'm going to stick with the easy equation today. So I'm going to take my D equals 90T. How many people feel comfortable with the decimal? Does it matter to you guys?
Just do 8 from 10. 8 by 10.
So my final answer is going to have the units of measure.
And you don't have to avoid how far.
It asked how far I lived away. It didn't ask anything about how far I traveled. So that's another really tricky thing with this is make sure you're answering the question that's being asked. Okay, can we go back and fix that second one? I love you guys. Okay, so you need an eraser. You guys all have your erasers up? You wrote in pen? Woo. I'm sorry. Or flip it over on the back side and start again. You got back side to something, don't I think we just redo the table. Anywhere you see an 80, I want you to replace it with what? Oh. Okay. All right, well, you want me just to start over? Yeah, I need a bigger razor. No, because then I'll take out the last example that we did, and I did it that correctly, so. Oh, can I move this stuff in? Everybody okay with that? It's okay. Hey, we made a mistake, we didn't have the eraser, everything's better. We didn't have the eraser, it's way easier, it's almost invisible. Okay, I need a pen this time. What's gonna motivate me? Okay, I'm gonna use a dark purple. Okay, all right. See, so much better. Okay. And that's why I bought the tables with the purple icing on it, because I really like purple. Okay, so we're gonna go and say my was right, and we're talking about the round trip, the total round trip. There's a half an hour so we're on the total round trip. So again, we're just gonna create our average, or not. We're gonna create our average formula. Fancy. So this is going to be S. Okay. Because that's the round trip. Yeah, if we were to add them together. It's still the same distance.
It's still slower by 50 kilometers.
It doesn't matter. The distance is still going to be the same. Okay, so slower is going to be S minus 16 equals 160 over. No. What? It's the T plus because it's taking us longer. Okay, so speed is being reduced, so that's the subtraction, but we're adding to time, like we're taking longer, so we're going to add on to the time. Okay, so we said we were going to rearrange this one, so this is going to be S equals 160 over T plus 0.5 plus 16. We said that these two things were equivalent, so we're going to set them equal to each other. What am I forgetting you guys are? Favorite people. All right, so we did non-permissible values of I hope you guys are writing this down better than I am. Okay, common denominator. Oh, look at that. Common denominator for this one, same thing. And you need both of them, right? It can't just be the second one. That's another common mistake that I see people make. They don't put this one because they're like, oh, there's a T in there. But there's nothing I can times T by that would give me an add 0.5. Does that make sense? Like, if I times T by 0.5, I get 0.5 T. I don't get point T plus 0.05. Anyway, okay, I'm going to stop. I think I did a comment. And do you guys include the one? The one? The one? What? The invisible one under the 16. Do you include that in your LCD? Mentally, they're not on paper. You guys don't do that. I I just want to see what you guys did. Okay, I found some stuff out. I'll go back to my purple. Okay, so I'm gonna multiply it right this time. So I have 160 T plus 80 equals 160 T, okay, plus 16 T squared. T times T is T squared. Remember that 16 is multiplied by both of these, right? So this is going to be plus 8T. Okay. I'm going to take out those 160s. This seems vaguely familiar. Do you guys feel like we've been down this road a couple of times? So 0 on this side, 16T squared plus 8T minus 80. This is still going to work right now. We're going to take our 8 out, so I'm left with 2T squared plus T minus 10. Oh, so much better. Oh, I feel so much better about this. So negative 20, 4 and 5. Positive 5, negative 4. So my 8 still stays out there. I should probably do this math off to the side. Yeah. Okay. So 2T squared plus 5T minus 4T. I probably could have done this a little bit better, but it will work out the same way. I know, but it will work the same way. So if I look at this, I'm going to take out a T. I'm left with 2T plus 5. I look at these two and take out a minus 2. And I'm going to be left with T, hang on, 2T plus 5. So my factors are 2T plus 5 and T minus 2. Okay, so we are going to solve these. I don't solve the 8 because there's no variable to actually solve for. So I'm going to have T equals okay, so looking at this, this is a real life situation. I can't have the negative time. So this one gets rejected based on context, by logic, yeah. Rejected by logic. You can't go well, you can go negative velocity, you can't go negative speed. Okay, and that's why we're only dealing with speed, we're not dealing in velocity, because we're just regular average people. And we're trying to drive a car, or a train. What? What can I solve 8 for? Is there a variable in there? 8 is 8, right? 8's a number. I'm solving for the unknown variable. There's no unknown with that 8. Okay, is that my answer? These two? Okay. What? Which one? We're going to use the easy one, right? It will work if you do it over here. You'll get the exact same answer, but you got to do more math. So let's do less math. What's the average speed? I wrote that down at the top. Dimension. Okay. Okay. Speed was 160 divided by time, which we said was 2. So my average speed, 80 kilometers per hour. Oh, I think we fixed them. Okay, we're smart. We're smart people.